Latent heat. What is latent heat? Give its units and explain the terms latent heat of fusion and latent heat of vaporization. Latent heat. When a solid changes into liquid or a liquid changes into gas, it absorbs heat. But this heat does not show up as an increase in temperature. This heat used to change the state is hidden or latent. Latent means lying hidden and is therefore called latent heat. The amount of heat required to change the state of unit mass of a substance at constant temperature and pressure is called latent heat of a substance. Latent heat of fusion. The amount of heat required to change the state of unit mass of a substance from solid to liquid at its melting point is called latent heat of fusion or latent heat of melting. Next, latent heat of vaporization. The amount of heat required to change the state of unit mass of a substance from liquid to vapor at its boiling point is called latent heat of vaporization or latent heat of boiling. The SI unit of latent heat is joule per kg. In CGS unit, its unit is calorie per gram. Next, what is the effect of pressure on the melting point of a substance? Effect of pressure on melting point. Under a given pressure, a pure substance melts at definite temperature. However, the melting point changes with the change in pressure. We know that paraffin wax expands on melting. An increase in pressure will make its expansion difficult. We will have to heat it more to melt it. That is, the increase in pressure increases the melting point of a wax. On the other hand, ice contracts on melting. The increase in pressure will help in its contraction. So we expect a decrease in the melting point of ice as the pressure on it is increased. We can generalize this observation as follow. The melting point of those substances which expand on melting, example paraffin wax, phosphorus, sulfur, etc., increases with the increase in pressure, while the melting point of those substances which contract on melting, example ice, cast iron, bismuth, etc., decreases with increase in pressure. Effect of pressure on freezing point of ice. Regelation. When two pieces of ice are pressed against one another for a few seconds and then released, they get frozen at the surface of contact. As the pressure is increased, the melting point of ice is lowered and ice melts. When pressure is released, the water so formed immediately freezes again. This phenomena of refreezing is called regelation. The phenomena in which ice melts when pressure is increased and again freezes when pressure is removed is called a regelation. Re means again, gelare means freeze. Practical applications of regelation. By pressing snow in our hand, we can transform it into a snowball. When snow is pressed, its crystal melt. As the pressure is released, water refreezes, forming a snowball. Second, when the wheels of cart pass over snow ice melts due to increase in pressure exerted by the wheels. When pressure is released, water so formed refreezes on the wheels. That is why wheels are covered with ice. Next, skating is possible due to the formation of water layer below the skates. Water is formed due to the increase of pressure and it acts as a lubricant. Next, the ice of glacier pressed against the sides of its valley melts and in this way adapts itself to the shape of the valley. What is the effect of pressure on the boiling point of liquid? Effect of pressure on the boiling point of a liquid. The boiling point of a liquid increases with the increase in pressure. At 1 atmospheric pressure, the boiling point of water is 100 degrees Celsius. At 2 atmospheric pressure, the boiling point of water is 128 degrees Celsius. To study the effect of pressure on boiling point, take a round bottom flask and fill it more than half with water. Support it over a burner and fix a thermometer and steam outlet through the cork fitted in the neck of the flask. Heat the flask over the burner slowly. As the temperature rises, small bubbles of water begin to form at the bottom, which rise through water and escapes from the surface. At a temperature about 70 to 80 degrees Celsius, bubbles of steam begin to form at the bottom. These bubbles of steam rise to the upper cold layers of water where they condense and disappear, producing a peculiar noise called singing of the vessels. As the temperature of the entire mass of water becomes 100 degrees Celsius, the bubbles of steam begin to escape more rapidly and water gets violently agitated and boiling is said to occur. As the steam comes out of the flask, it condenses as tiny droplets of water, giving a foggy appearance. If the steam outlet is partially closed, the pressure inside the flask increases and boiling stops. Water now has to be heated to a higher temperature to make it boil again. Thus, the boiling point increases with the increase in pressure. Remove the burner and allow the water to cool a temperature below 100 degrees Celsius. If the pressure is reduced by removing the partial covering of the outlet, water begins to boil again. Thus, the boiling point decreases with the decrease in pressure. Practical applications. Cooking is difficult at mountains. The atmospheric pressure at mountains is much lower than that at plains. So, water starts boiling at a temperature much lower than 100 degrees Celsius. Hence, cooking is difficult. Next, the pressure inside a pressure cooker is increased much above the atmospheric pressure by not allowing the steam to escape. This increases the boiling point. Hence, the vegetables are cooked inside a pressure cooker in a shorter time. Franklin experiment. Take a round bottom flask and fill it about half with water. Heat it so that water begins to boil. Continue boiling for some time so that air of the flask escape to the atmosphere and the empty space is filled with steam. Remove the burner. Close the flask with airtight cork. Hold the flask in the clamp of a stand in an inverted position as shown. Allow the water to cool for some time so that boiling stops altogether. Pour cold water on the flask. Due to the condensation of steam, the pressure over the water surface decreases. Water begins to boil again, now at a lower temperature. This shows that the boiling point decreases with the decrease in pressure. The change of state from solid to liquid is called melting, and from liquid to solid is called fusion. The change of state from liquid to vapor is called vaporization. Melting point. The temperature at which the solid and the liquid states of a substance coexist in thermal equilibrium with each other is called its melting point. It is the characteristics of the substance but also depends on pressure. The melting point of a substance at standard atmospheric pressure is called its normal melting point. Boiling point. The temperature at which the liquid and vapor states of a substance coexist in thermal equilibrium with each other is called its boiling point. The boiling point of a substance at standard atmospheric pressure is called its normal boiling point. Sublimation. Some substances on being heated pass from the solid state to liquid state directly. The process of transition of a substance from the solid state to the vapor state without passing through the liquid state is called sublimation, and the substance is said to sublime. Substances like dry ice, solid carbon dioxide, iodine, naphthalene, camphor undergo sublimation when heated. During the sublimation process, the solid and vapor states of a substance coexist in thermal equilibrium with each other. Calorimeter. It is a device used for measuring the quantities of heat. It consists of a cylindrical vessel of copper provided with a stirrer. The vessel is kept inside a wooden jacket. The space between the calorimeter and the jacket is packed with a heat insulating material like glass, wool, etc. Thus, the calorimeter gets thermally isolated from the surrounding. The loss of heat due to radiation is further reduced by polishing the outer surface of the calorimeter and the inner surface of the jacket. The lid provided with holes for inserting a thermometer and a stirrer into the calorimeter. When bodies at different temperatures are mixed together in the calorimeter, heat is exchanged between the bodies as well as with the calorimeter. If there is no loss of heat to the surroundings, then according to the principle of calorimetry, heat gained by cold bodies is equals to heat lost by hot bodies. This equation can be used to determine the specific heat and latent heat of different substances. Calorimetry. The branch of physics that deals with the measurement of heat is called calorimetry. Principle of calorimetry or the law of mixtures. Whenever two bodies at different temperatures are placed in contact with one another, heat flows from the body at higher temperature to the body at lower temperature till the two bodies acquire the same temperature. The principle of calorimetry states that the heat gained by the cold body must be equal to the heat lost by the hot body, provided there is no exchange of heat with the surrounding. This principle is a consequence of the law of conservation of energy and useful for solving problems relating to calorimetry. Heat capacity or thermal capacity. The heat capacity of a body is defined as the amount of heat required to raise its temperature through 1 degree. Its CGS unit of heat capacity is calorie per degree Celsius and the SI unit is joule per Kelvin. Molar specific heat. The molar specific heat of a substance is defined as the amount of heat required to raise the temperature of 1 mole of a substance through 1 degree. CGS unit of molar specific heat is calorie per mole per degree Celsius and SI unit is joule per mole per Kelvin. Specific heat. The specific heat of a substance may be defined as the amount of heat required to raise the temperature of unit mass of the substance through 1 degree Celsius. The CGS unit of specific heat is calorie per gram per degree Celsius and SI unit is joule per kilogram per Kelvin. Anomalous expansion of water. Anomalous expansion of water. Almost all liquids expand on being heated, but water behaves in a peculiar manner. When water at 0 degrees Celsius is heated, its volume decreases and therefore its density increases until its temperature reaches 4 degrees Celsius. Above 4 degrees Celsius, the volume increases and therefore the density decreases. Thus, water at 4 degrees Celsius has the maximum density. Practical importance of anomalous expansion of water. The anomalous expansion of water has a favorable effect on aquatic life since the density of water is maximum at 4 degrees Celsius. Water at the bottom of lakes remain at 4 degrees Celsius even if it freezes at the top surface. This allows marine animals to remain alive and move freely near the bottom. If water did not have this property, lakes and ponds would freeze from the bottom up, which would destroy the entire aquatic animal and plant life. Expansion of a liquid. When a liquid is heated, its container also expands. The observed expansion of the liquid is called apparent expansion, which is different from the real expansion of the liquid. Next, coefficient of apparent expansion. It is defined as the apparent increase in volume per unit original volume for 1 degree rise in temperature. Next, coefficient of real expansion. It is defined as the real increase in volume per unit original volume for 1 degree Celsius rise in temperature. Practical applications of thermal expansion. A small gap is left between the iron rails of railway tracks. The two rails are joined by fish plates. If no gap is left between the rails may bend due to expansion in summer and the train may get derailed. Next, space is left between the girders used for supporting bridges. This allows their expansions during summer. Moreover, the ends of the girders are placed on metal rollers to allow the expansion and contraction to take place easily with the change of season. Next, the iron ring to be put on the rim of a cart wheel is always of slightly smaller diameter than that of the wheel. When the iron ring is heated to become red hot, it expands and slips onto the wheel easily. When it is cooled, it contracts and grips the wheel firmly. Clock pendulums are made of invar. Invar is an alloy. It has extremely small temperature coefficient of expansion, so the length of invar pendulum does not change with the change of season, and the clock gives almost correct time. A glass stopper jammed in the neck of a glass bottle can be removed by warming the neck of the bottle. When the neck of the bottle is slightly warmed, its mouth becomes slightly wider. The stopper becomes loose and comes out easily. Only platinum wire is used for fusing into glass. This is because the coefficient of thermal expansion of platinum is almost the same as that of glass. Why do solids expand on heating? Cause of thermal expansion. All solid consist of atoms and molecules. At any given temperature, these atoms and molecules are held at equilibrium distance by forces of attraction. When a solid is heated, the amplitude of vibration of its atoms and molecules increases. The average interatomic separation increases. This results in the thermal expansion of the solid. The increase in the size of a body when it is heated is called thermal expansion. Different types of thermal expansion: linear expansion, superficial expansion, cubical expansion. Linear expansion, it is the increase in the length of a metal rod on heating. Superficial expansion, it is the increase in the surface area of a metal sheet on heating. Cubical expansion, it is the increase in the volume of block on heating. Advantages of using mercury as a thermometric substance as compared to other liquids. Mercury has a uniform coefficient of expansion over a wide range of temperature. Mercury is opaque and bright, so its level can be seen easily in a glass tube. It does not stick to the walls of the glass tube. It is a good conductor of heat and so attains the temperature of the hot body quickly. It has low specific heat. It absorbs very small amount of heat from the body whose temperature is to be measured. The range of mercury thermometer is quite large because of its low freezing point -39 degrees Celsius and high boiling point 357 degrees Celsius. Mercury is non-volatile. What is meant by triple point of water? What is the advantage of taking triple point of water as the fixed point for a temperature scale? Triple point of water. The triple point of water is the state at which the three phases of water, namely ice, liquid water, and water vapor, are equally stable and coexist in equilibrium. It is unique because it occurs at a specific temperature of 273.16 Kelvin and a specific pressure of 0.46 centimeter of Hg column. In modern thermometry, the triple point of water is chosen to be one of the fixed points as it is characterized by a unique temperature and pressure. So, it is preferred over the conventional fixed points, namely the melting point of ice and boiling point of water. The melting point of ice and boiling point of water both change with pressure. Moreover, the presence of impurities changes their values, but the triple point of water is independent of the external factors. In the absolute Kelvin scale, the triple point of water is assigned the value 273.16 Kelvin. The absolute zero is taken as the other fixed point on the scale. Thermometric scales. The range between the two fixed temperature is called fundamental interval, which when divided into a suitable number of equal divisions forms a thermometric scale. The commonly used temperature scales are the Celsius scale, the Fahrenheit scale, the Reumer scale, the Kelvin scale. The Celsius scale. On this scale, the lower fixed point, ice point, is taken as 0 degrees Celsius and the upper fixed point, steam point, as 100 degrees Celsius. The interval between the two fixed point is divided into 100 equal parts, hence the name centigrade, and each part is called 1 degree Celsius. Next, the Fahrenheit scale. On this scale, the lower fixed point is taken as 32 degree Fahrenheit and the upper fixed point is 212 degree Fahrenheit. The interval between them is divided into 180 equal parts and each part represents 1 degree Fahrenheit. The Reumer scale, the REAUMER Reumer scale. On the scale, the lower fixed point is taken as 0 degree R and the upper fixed point as 80 degree R. The interval between them is divided into 80 equal parts and each part represents 1 degree R. Next, the Kelvin scale. On the scale, the lower fixed point is taken as 273.15 Kelvin and the upper fixed point as 373.15 K Kelvin. The interval between the two fixed points is divided into 100 equal parts. The SI unit of temperature is Kelvin. What are two fixed points on a temperature scale? Fixed points on a temperature scale. To construct a temperature scale, two fixed points, two well-defined thermodynamic states are chosen and are assigned to arbitrary numbers for their temperature. One number fixes the origin of the scale and the other fixes the size of the unit of the scale. The temperature at which pure ice melts at standard pressure, ice liquid water equilibrium state, is usually chosen as the lower fixed point. The temperature at which pure water boils at atmospheric pressure, liquid water vapor equilibrium state, is chosen as the upper fixed point. Principle of thermometer. A thermometer makes use of some measurable property called the thermometric property of a substance which changes linearly with temperature. The thermometric properties of different substances and the corresponding thermometers are as follows. Length of a liquid column in a capillary, mercury thermometer. Pressure of a gas at constant volume gas thermometer. Volume of a gas at constant pressure gas thermometer. Electrical resistance of a metal wire, platinum resistance thermometer. Thermoelectrical EMF, thermoelectric or thermocouple thermometer. Radiated power pyrometers. Thermometer. Any device used to measure the temperature of a body is called a thermometer. It is named so because thermo is a Latin word which means heat and meter means a measuring device. Thermometry. The branch of physics that deals with the measurement of temperature is called thermometry. Difference between heat and temperature. Heat. Heat is a form of energy which produces in us the sensation of hotness or coldness. Temperature. Temperature is the degree of hotness or coldness of a body. Heat. It is caused when some heat is supplied to a body, its temperature increases. Temperature. It is an effect. Heat. It represents the total kinetic energy of the molecules of a body. Temperature. It represents the average kinetic energy possessed by the molecules of a body. Heat. Heat flows from high temperature side to low temperature side, irrespective of the amount of heat possessed by the bodies in contact. Temperature. Temperature decides the direction of flow of heat from one body to another. Heat. It is measured in calorie, kilocalorie or joule. Temperature. It is measured in degree Celsius, degree Fahrenheit or Kelvin. Kinetic interpretation of temperature. The temperature of a body is the measure of average kinetic energy of its molecules. When a body is heated, its molecules move faster. Their average kinetic energy increases. This increases the temperature of the body. In thermodynamics, the concept of temperature follows from the zeroth law of thermodynamics. Explain the concept of temperature. Temperature is the degree of hotness or coldness of a body. When two bodies are placed in contact, the heat flows from the body at higher temperature to the body at lower temperature. Thus, temperature may be defined as the thermal state of a body which decides the direction of flow of heat energy from one body to another when they are placed in thermal contact with each other. What are the CGS and SI units of heat? How are they related to one another? CGS unit of heat. The CGS unit of heat is calorie. 1 calorie is defined as the heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. SI unit of heat. Like all other forms of energy, the SI unit of heat is joule. 1 calorie is equals to 4.186 joule. What is meant by the statement that heat is the energy in transit? Heat is the energy in transit, the energy associated with the configuration and random motion of molecules in a body is called internal energy. The part of this internal energy that is transferred from one body to another due to temperature difference between them is called heat. Clearly, the word heat is meaningful only as long as the energy is being transferred. The expression like heat in a body or heat of a body are meaningless. So, we define heat as the energy in transit that flows from one body to another due to temperature difference between them. Once heat is transferred to a body, it becomes a part of its internal energy. Depending on temperature and nature of the substance, the molecules may possess three types of motion: translatory motion, vibratory motion, rotatory motion. Translatory motion. This is the motion in a straight line, which is common in gases. Vibratory motion, that is the to and fro motion of the molecules about their mean positions. This is common in liquids and gases. Rotatory motion, that is the rotation of the molecules about their axis. This occurs usually at high temperatures. When a body is heated, all these molecular motions become fast. The kinetic energy of a molecule due to each type of motion increases. So, we can regard heat as an energy of molecular motion which is equal to the sum total of the kinetic energy possessed by the molecules of a body by virtue of their translational, vibrational, and rotational motions. Dynamic theory of heat. According to this theory, all substances, solid, liquid, gases, are made of molecules. These molecules are in a state of continuous random motion. Caloric theory of heat. According to this theory, heat is an invisible, weightless, and odorless fluid called caloric. When some caloric is added to a body, its temperature rises, and when some caloric is removed from a body, its temperature falls. However, this theory failed to explain the production of heat by friction, so this was replaced by dynamic theory of heat. Heat. Heat is a form of energy which produces in us the sensation of hotness or coldness. For example, if we touch a piece of ice, heat flows from our body towards ice and we feel cold. Similarly, when we stand near a fire, heat from the fire flows towards our body and we feel hot. Thank you.